Hey everyone, Radhe Radhe. Um, so we are changing our whole time doing it like for the first time at this particular moment. So it's new for me. I'm just just kind of testing if it can work pretty well, and if it does, then I can shift my whole timing as well. Let's gonna play around with brightness as well. Camera doesn't look as great, neither that bad either. Yeah, that's cool. Awesome. All right, so today we'll be discussing about the Kubernetes conference. We'll kind of reverse engineer them again. We'll try to get over the whole components of the Kubernetes, as well as also try to uh, understand some of the observability stack as well of Kubernetes, because it is kind of a really important topic, a really important domain within the whole Kubernetes zone in the cloud native as well. Like the observability does holds a really special spot when it comes to the Kubernetes and the whole CNCF landscape as well, because that's where you actually get to see how can you solve a lot of issues and ease out the whole troubleshooting process as well, because uh, you'll be getting a particular kind of uh, you'll be building around a certain kind of an architecture which will be considering to capture the traces that has been formed by a lot of different API interactions, as well as also the services interaction within the whole microservice architecture. Uh, Whenever you like for any particular engineer, any particular platform engineer, or even a DevOps engineer, or any Kubernetes engineer, either any software engineer, they might have been handling along with it a lot of different API services, a lot of different the services that might have been deployed to their architecture, a microservice kind of multi-service and microservice kind of an architecture at that time over there. There may be a lot of different services that might be interacting along with each other. Like you might be having a whole IDP kind of an environment, you might be having a whole platform engineering uh, platform, like developer platform for your team, for your server, for your whole organization. At that moment, you might be using a lot of different services at different levels. Whether it could be the Prometheus, whether it could be Grafana, it could be nothing else either. Like if you are you there'd be a lot of different microservices that would be deployed. Let's say if let's take an example of Facebook. It will be having a database model. So that would be a particular service that would be deployed or being interacting at the same time. Like there will be a database whole service. There'll be an observability service as well, which will take care of observing the whole matrices as well that's been going on at the moment. There might be some kind of the cache server as well, which will be catching and collecting the cache from your server. There'll be let's say some other services that might be running at the moment. So out of all of these particular services that might have been deployed to your service or to your microservice architecture over there, there could be there will be a lot of different interactions between all these particular services or between all these particular microservices, and these all interactions will be taking place with the API headers, like the API headers or the HTTP headers. I am saying API requests that would be passed from one service to the another service that might be placed or being present at some other place in your whole architecture. So they will be interacting along with each other. They'll be interacting through APIs with the help of the HTTP headers, and all of those HTTP headers will be passing on a lot of different methods and a lot of different like the get method or post method or delete method, update, or the CRUD operation that might have been going on at the moment. So that's the whole point of it. And in microservice architecture, there will be a lot of different services that will be interacting along with each other, and they'll be like if they are interacting along with each other, they'll be producing a lot of different traces of all of these particular interactions, and these traces will help any particular the developer, software engineer, to get the a better understanding of the whole architecture in which and the computer have been working at the moment. So that's the whole point of it. There are two people at the moment. Welcome. Let me know if you guys, if I'm kind of visible at the moment. Right. So I'm saying for any particular person who just entered the whole in this live at the moment, we are talking about discussing just reverse engineering the whole Kubernetes domain as well as also an open telemetry. So yeah, I was just saying that in a microservice architecture, your different services will be interacting along with each other through HTTP headers, and those interactions will be creating a lot of traces. Those traces will help eventually any particular developer to understand their whole architecture in a well manner, in a lot better format, as well as also form out different patterns, as well as also form out different patterns and try to make predictions as well, future predictions as well for the service, for the whole architecture as well. In that scenario, we'll in that case, through that case, we'll get to know about them all. For anyone who doesn't know anything about open telemetry, let me just break it down. The whole term is well. It's kind of an easy thing. Like the open telemetry includes open, that because it's open source. It is a standards that has been set by the community for the logs, for the capturing of the logs, metrics, as well as the traces. Because at earlier stage, when the whole development wasn't as much introduced or being that much evolved at that time, the developers were also kind of really struggling really hard in order to migrate all the information that has been captured through the logs, traces, and matrices whenever they are changing their services. Like if they are changing their services from a any particular SaaS, I would say application, not an application, but let's say any particular public cloud. Let's say if they are shifting from the AWS to the microservice Azure. In that scenario, the logs, traces, and the matrices that might have been captured at any particular public cloud would be like it would be really difficult to migrate to a newer service. In that scenario, that's why they, instead of just jumping over different particular public clouds or the services, they created a standards by the whole for the whole community that was being termed as the open telemetry. So we'll be trying we'll try to see it, what we know about them, and we'll try to learn a bit more about them as well. Let me share my screen. um, as always, we'll consider we just hop on to this whole list of different live streams that we have organized till now. One of them was the Kubernetes and the K gateway and all of them. In the last stream, we discussed about the some of the components of Kubernetes. So yeah, we are just kind of reverse engineering the whole thing, because if you are a good engineer, then it is really important for you as well to just know about the systems that you've been using at the moment, instead of just using the tools and without having any particular knowledge about them at all. We've been coding a lot in Go as well as also in Rust. I haven't started of any particular lecture of Rust till now. That's why we didn't have. I haven't organized any particular live stream in Rust till now, but we'll soon. It was one of the topics that was kept, that is kind of a pending topic since the second live on our channel. All right, so today we'll be discussing about Opentelemtry. Yeah, yeah. If any particular person want to access this particular document, then I have left a link to this Google Doc in the description. They can also get uh, access to this Google Doc. Let me see if I'm, yeah, right. Network is a bit stable. That's awesome. Thanks. All right, we have entered the double-digit club of lives and open telemetry. reverse engineering Kubernetes observability with OpenTelemetry insights. Right, I make it bold. Awesome. These all are awesome. Understand the right, and that's just a great definition. I know. Hey Shreyans, good to see you, man. Again, Radhe Radhe, everyone. I guess I had some links earlier. Alright, so let me break down the whole name of OpenTelemetry, what this stands for. In starting, Open usually stands for the open source because it is an open sourced project. That's why it's been termed as an open telemetry. Other than that, tele is been named as like the meaning of tele is just it's a technique that helps you in connecting between different matrices. Matrices are stands for the measurements. It is a term that is that does mean about the measurement. So that's why it's been a technique, an open source technique that is really useful for any particular developer who really wants to get the measurements, a certain kind of measurements of their computer, of their architecture, of their whole application that they've been working on at the moment, which are in the form of the logs, traces, as well as matrices. Logs are the detailed information about the different activities as well as different interaction that might have been taking place OA application between different services and the whole microservice architecture. And the traces are the ones that has been left behind by the different API I would say interactions that have been taking place at the moment by different services. And metrics are a lot, they are kind of like the summary of all those particular logs. They does hold the same meaning, but they are a bit less less messy. Right, so let's I don't want to give any particular kind of what would I say? Uh, let's just hop on to the whole project's documentation because it would be a lot better if we can just hold on to the real like the original definition of any particular concept of the project as well. OpenTelemetry docs. Also, we have let me share it as well. Awesome. So, OpenTelemetry, also known as OTel, is vendor neutral. Yeah, that's the whole point of it. Like, there were a lot of restrictions that were being made earlier by a lot of different services that were being used by the developers communities. Like the AWS was having its own rules, and all these particular services that were being provided at that time, they used to freeze the flexibility that was being provided to the developers or any particular service or project that were being owned by any individual or community, so that they can't easily migrate to another environment or the service that's available in the whole market. That's really bad because vendor lock-in policies are really bad for any project to operate or scale in long term. So that's why new projects you might have heard about the no vendor lock-in policies is a really, I would say, it's a lot more. It's kept at a lot priority based uh, kind of thing at the moment, because you'll see a lot of different projects that are being that are mostly open source. They won't have any such kind of a lock-in policy for their project. While on the other hand, you'll see that the AWS and Azure and the Alibaba Cloud or GCP will have a lot of like all of those particular services will be having this vendor lock-in kind of thing. That's not a good thing. All right, so let me add this docs as well. Link to OpenTelemetry. By the way, if you are a Golang developer who's searching for a project, OpenTelemetry, like you can work on top of OpenTelemetry collectors, but it won't be as, because OpenTelemetry has been built in C and C++, so that's why it isn't for, like, it is for a person who's coding in C, because in Go, because Go is also its syntax is more closer to C and C++. Although I don't think its concepts are, because it doesn't hold as much inheritance concepts as well. It's a bit different, I would say. Right. So here we have OpenTelemetry, also known as OTel, is a vendor neutral open source observability framework for instrumenting, generating, collecting, and exploring telemetry data for traces, metrics, and logs. That's what I said. As I said, it will be having a lot of different microservices, which will be including OTel instances, OTel APIs, SDKs, and collector. It is being designed in Go. Got uh, you might have seen it being designed in some other languages as well. Let me show it. Let me show the GitHub page. It is OpenTelemetry, 6.5 followers, 6.5K. Here we have the community that's been built in Python. OpenTelemetry specs, a markdown, telemetry.io. It's this whole project has been built out in JavaScript, and the OpenTelemetry demo is also in TypeScript. Awesome. It's in Ruby, and the operator has been built out in Go. Character is also built in Go. So these are really important parts that are both built in Go. So it is a project. If you are a Golang developer, you can contribute to both of these particular components of OpenTelemetry. It's huge, updated 8 minutes ago. So as you can see, it is really awesome. So let me just kind of change my location again, because yes, I can see, and some of the people are also commenting that the light, like the brightness, isn't as good over here at the moment. So let me just change it real quick. Hey, let me increase my brightness. Then let me just share this screen instead because there should be something uh, for the community as well in case they want to see what's, what they have to be. That's the whole chart. You can view it. Let me just adjust my brightness till then. Nah, that's too dark still. Right. Right. So we have the whole documentation of OpenTelemetry. It's just getting started documentation, I guess. What is OpenTelemetry? Let's look at it. Brief explanation of OpenTelemetry is and isn't. I told you what does it mean? What is OpenTelemetry? It is a set of structure standards that has been set by the community in order to play around with the log traces as well as matrices in order to generate them, export them, and save and use the collection that has been used earlier in our earlier solution for the whole architecture. And then later we can just whenever we are trying to migrate to the new service, at that moment we can use the same the collections or the traces or any particular standard that we have defined in the earlier architecture of our service. So that's the whole point of OpenTelemetry. About what it isn't is that there isn't a solution that can help you in setting up, or let's see, isn't a particular solution that can help you in getting in solving out the matter of the whole uh, the issues that usually comes up along the traces, matrices, and all of these particular things. Whenever if you're trying to play around along with the logs, or like if you are playing around along with the matrices, then in that case you can just use instead of OpenTelemetry, you can use some of the solutions that are the Prometheus as well as Grafana. If you are playing around with the logs, then you can use the Grafana Loki as well as Prometheus as well, and the FriendDB. And if you are using the like the events, if you're playing around with the events, then in that case you can use the Kspawn. Right. So that's all about the what it is and what it's not. Let's look at its documentation as well. Should we watch this video as well? Let's have a look at it as well.
Hi, welcome to OTEL for Beginners. My name is Lisa Jung, and I'm a member of the OTEL Communication SIG and End User SIG. I recently began my journey with OTEL, and as a newbie, I had a tough time figuring out how to get started. I want you to have a different experience
Oh, got it. I guess it was mute, so that's why it was not audible either. I just played again. Yeah, Yom Chaudhary. Hey, dude.
Hi, welcome to OTEL for Beginners. My name is Lisa Jung, and I'm a member of the OTEL Communication SIG and End User SIG. I
I think
recently
it
began
is
my journey
audible
with
right
OTEL,
now.
and as a newbie, I had a tough time figuring out how to get started. I want you to have a different experience, so I'll learn alongside you and share what I'm learning through the series. Depending on which programming language you're working with, you'll follow a language specific journey. In this series, I'll go through the JavaScript journey to get you started with OTEL. Before we get our hands dirty, let's talk about what OTEL is, why you should consider using it, and the resources to get started. OTEL stands for Opentelemtry, and it plays an important role in observing your system. So let's talk about observability first, then delve into how OTEL fits into all of this. Our modern software systems can consist of complex, multi layered, and distributed systems with many interdependencies. A system without observability is like a black box. We have no idea what's going on inside. So if something goes wrong, it's going to be more difficult and more time consuming to solve the problem. With observability, we turn this black box into a glass box. As a matter of fact, it helps you collect the data necessary to visualize and understand what's going on in your system. How do we make this possible?
Alright, stop. I don't want to make this whole. Uh, I want to make the whole 9 minutes just listening to this video. So that's why I just gonna hop in with the main definition as well, or the breakage of the open telemetry into different components that makes up this whole stack. With the observability, it's logs, tracy as well as matrices. It isn't gonna necessary thing to just look up on the video, because it would be a lot better if we just look at the documentation and get to know about the whole component from there, instead of just getting to know about the stack with the help of a YouTube video. Uh, Observability is the ability to understand the internal state of a system by examining the outputs. In the context of software, this means being able to understand the internal state of a system by examining its telemetry data, which includes traces, metrics, as well as logs. I guess it will take us to, um, let's see, yeah, that does. I was thinking they might drag us back to some Kubernetes page that holds the definition of traces. No, it's good. It does holds a pretty nice docs. This is give us a big picture of what happens when a request has been made to the application. That's what I said. Uh, Whether an application is monolithic with a single database or sophisticated mesh of services, traces are the essentials to understand the full path of request take in your application. All right, so let me introduce you. Like, gonna tell you how does all these particular things usually works. Let's say you have a whole application that's been working on top of some of the multi the microservices. And let's say you have a microservice application that is holding a lot of different services that are being bound together with the help of different pipelines. So there must be a lot of different interactions between all of these microservices with the help of the HTTP headers. So they'll give HTTP headers. Those particular HTTP headers will be essential, because they'll be kind of interacting with each other with the help of different methods, like the API methods of get, post, and update. All of these particular things, whenever they'll be interacting along with each other, they'll be kind of just creating the traces. These particular traces are also being called as the spans. These builds up the whole telemetry context, because whenever one particular service has been contracting along with the another service, then in that case the whole you know the telemetry context that has been formed in the form of the span would be collected and will be stored in the whole uh, let's say the context table of context of the different services. And whenever that that particular information that has been passed to the second service, if it get forwarded to the third one, to the third service as well through any particular pipeline, then that context will also get passed on to the third service, and that third service will either it will use the existing span that is being passed from the first or the second service or the third one, or either it will create its own span, and that span would be kind of that get appended in the existing span tree. So that's the whole scenario in which the whole different spans are being created, and in this way, the open telemetry trees are also been built for all of the different telemetry scenario. Let's read a bit more about the whole thing. Like that's how the whole iterations usually occurs. If you're having a particular architecture of an application, let's say you have just kind of triggered a particular kind of action by passing some of the values or some kind of an input to the front end. That front end will be having its own span as well as HTTP methods as well. It will be passed on to the backend service, and that backend service will be having its own span that would be added to the the table of contacts, and it will be passed on to the third service. Let's say the database as well. The fourth one could be the cache memory, because if you are using it a lot more, then it could be it can share as a cache memory, or we can bring the cache memory before database as well. So it all depends upon the whole solution architecture and kind of a thing as well. All right, so let's read a bit more about the traces. Like these spans are the smallest unit of work that has been done in the telemetry. That is what it's saying. Let's explore with three units of work that has been represented with spans. One is hello, then null, and the third one is gluten time. Has been passed. The name has been set to hello for this particular span. Hello span, that's what I said. Yeah, hello span didn't had any prior service that has been passed to it. That's why its parent ID is null. Like within a span, you will have certain different things. Like you'll be having a span, like context, its manufacturing time, its ending time as well of any particular span that has been passed to the service, like the name, start time, as well as the end time. Let's see if the network is it's stable. Awesome. The second one is hello greeting span. This is the root span denoting the beginning and the end of the entire operation. Note that there is a trace ID field indicating the trace. So these all things makes up the traces. I don't want to see it as much. I want to see. Let's jump back to. Just gonna jump back to the GitHub's code instead in the OpenTelemetry. Like we were talking about the OpenTelemetry controller that's been handling the whole thing of context passing as well. So let's try to look into that particular project that has been coded in Go. So that's why we'll be able to understand what's been going on over there. It's been updated in 28 minutes ago. That means the community is pretty much updated. That's awesome. Hotel Platin EU is coming to Brussels February 2nd of 2026. It's the conference day at FOSDEM. Let's read the README. OpenTelemetry Collector offers a vendor-agnostic implementation on how to receive, process, and export telemetry data. In addition, it removes the need to run, operate, maintain multiple agent collectors in order to support open source telemetry data format. Like whenever you've been interacting or like using the services that have been provided by Jaeger, Prometheus, Grafana, Datadog, and a lot of other solutions as well. Fluent Bit as well, Fluent D, Fluent Bit. The multiple open source or commercial backends. Objectives is reasonable default configurations. If you want to be a part of this community, then you can like have some video calls that have been slotted in these three timestamps. On Tuesday it would be 17 BT Pacific time, 1700. On Wednesday it would be 900 and 500 Pacific time. Contributing to the project are also welcome. To the ad hocs, compatibility, verifying the image signatures, cosign verify. Let's learn a bit about the Go files. I want to see a particular method that has been implemented over here. Let's view over some of the, at least I guess we can look over at some of the demos as well. It might have been passed with the whole repo pipeline, consumer docs, config maps, component cmd config, and these are different components like the like connector, consumer, all of these, hotel call, internal. Let's look at the client. Client is also another client.go. Yeah, we shout out to the whole community as well of OpenTelemetry, authors who have told me, and Andres Stencil. Package client contain generic representation of clients connected to the different receivers. Components such as processors or exporters can make use of this information to make decisions related to the grouping to batches, tendencies, load balancing, and tagging along with others as well. Structure has been defined here, typically used within the context that is propagated down to the pipelines. So it is explaining about different components as well. That's awesome. Oh, we have the whole configuration file as well. Producers, receivers are responsible for obtaining a client info, client.info from the current context and enhancing the client info with the net address, and then storing a new client.info into the context that it passed down. Once it requires the new net address is typically the IP address of the client. Typically, however, receivers would delegate this process to helpers. All right. Provided that the pipelines does not contains we the authenticators are responsible for obtaining a client.info from current context, enhancing the client info with an implementation of client or data, and storing a new client info with the context that it passed down. Authenticators are responsible for obtaining a client's info from the current context, enhancing the client's info with an implementation of client auto data, and storing a new client's info with the content that it passes down. The database name should be documented. Like it will be responsible for the authentication parts. All these authenticators. Receivers will be responsible for obtaining the client's info so that they can perform the further operation that has been passed on in the whole stack tree or the telemetry or the context tree. Typically, however, receivers would delegate this process to helpers such as the config HTTPs or config gRPC packages. Both contains interceptors that will enhance the context with the client's info. Consumers, provided the pipeline does not contain processes that would be discard or rewrite the context, such as the batch processes, processors, and exporters, have access to the client info via client context. Let's jump on to the Go part, I guess. It will be a lot better and easier for us to understand. So it is importing context, iter, and maps, net and strings as well. Alright. Struct has been an empty struct has been passed. That is CDS key, and an info struct has been passed. That will be using net dot address. Yeah, we're referencing this particular library that we have imported. That is net address. I guess they have mentioned above that net address would be considered as the IP, right? Hmm. Oh here, yeah. With the net address on peer, nah, they haven't. Guess over here they might have mentioned about. I think yep, net address is the IP that we have been passing down. Receiver are responsible for obtaining a client's info from the current context and enhancing the client's info with the net address from the peer storing a new client's info. The net address is typically in the IP address of the client, where in this case, exactly. Net address is the IP of the client address for the client connecting to the collector, available in the best effort basics and generally reliable for the receivers making use of config HTTP to server and config gRPC to server options. Auth data, there is the authenticator that we discussed about earlier. All the information of the incoming requests are provided by the config auth server authenticator implementations tied to the receiver for these connections. Metadata is the request metadata for the client connection to the connectors. Metadata. Then we had auth interface. I'll be using this struct, I guess. Yep. Get attribute names. Get attribute would be containing like its argument would be a string. That's why we have just parsed a particular string with the help of which we'll be getting the attributes of any particular output that would be provided back as a result. The get attribute names, it will be containing a particular string or a whole list. It could be a list, it could be an array of these strings. In this case, I guess they've been pointing out to using an array. Const metadata host has been passed as host. I guess we'll be using this as well. Metadata host. And when it comes to the get attribute string, let's see. We'll have new metadata, event and key literal initialization. New metadata will be calling out context with values, context, key, and C. C is info and context is context.context. Metadata string, it will be passing, like making up a map of data, where the key would be the string and the output would also be provided as a string. New metadata is also same, keys, cat as well. Yeah, J Pandey. Right, so the Opentelemtry usually stands out as a particular kind of a standard for any particular person who does want to get kind of the whole grasp over the logs, traces as well as the matrices. For any particular engineer who's been handling out the whole microservice architecture, it becomes really important to handle the different traces, logs as well as matrices as well. Traces are some of the particular, like just as the human races as well. Whenever we usually, you might have heard about like the traces in case of the a lot of detective movies as well in that scenario. In the same way, a particular developer would be using those particular traces. Those traces are the HTTP interaction that is just uh, took place between different APIs and as well as services. All right, so that was about the OpenTelemetry. OpenTelemetry usually contains its name usually includes open, that stands for the open source. Telemetry's meaning is like the technique that has been used to measure, to like iterate over the measurements as well, or understand about the measurements. So that's why it's really important for you in case you want to get a really nice grasp, or you want to understand more like the functioning of the whole uh, architecture of your application. Like if like open telemetry is also like it's a standard that has been developed by the whole community in case they want to make sure they are using their logs, traces, as well as also their matrices. They have been monitoring them all in the well vendor lock-in free kind of an environment, and it would be a lot more tool agnostic, meaning they'll be able to import these different standards that might have been defined in different environments while they are migrating between different services, whether it is Jaguar or it is like the Jaeger, or either it is Prometheus, Datadog, Grafana, any particular solution that they have been using at the moment. And if they got kind of just migrate over to the another solution, then it would be a lot better. It would be a lot easier for any developer to iterate over the different the traces that they might have catched over grace of time. Right, so the auth data is the authenticator, metadata host includes the host part, new context. Let's roll back a bit. New context will be using context c info, going out context and returning the values with values. Yep, see, it's same. From context, it would be running up a boolean as well, boolean check. If it is true, then it will be providing like returning back C along with the bunch of info that has been required. Otherwise, if it is like kind of being termed as false, like if it isn't okay, it's if it is false, then in that case it will be returning the info with an empty record as well. Otherwise, it will just return C that has been captured over the RAM. Metadata is an immutable map meant to contain the request metadata. Yeah, sure. It's just a map. It's immutable. Like if your reason no was immutable, then I would suggest you to understand about Kubernetes again. The Kubernetes is an immutable kind of a structure in which the whole thing usually gets down. It usually gets deleted if you are changing any particular kind of a service. Otherwise, if you're just changing it and iterating on the same version, it might introduce a lot more security gaps as well. Like from the Docker perspective as well, if it does have some CVs that has been passed and um, haven't been solved by engineers, then it will be passed on to the next version as well that has been changed, and that whole kind of a security threat would be continued in the further processes as well. And that won't be good for your architecture, for your application. If you're a solution engineer, it will really mess up with the whole solution that has been provided by you. So new metadata would be map md metadata c as well, and is a really easier file, to be honest, if you ask me. Let's make up the whole map as well. This thing would be really interesting. Like the new metadata would be making up map, the key string, and the length of the map as well. It would be passed on with the variable c for k and v in range of the whole map. Strings dot to lower will be set to the lower case for the k is equals to v. Fine. Return metadata that has been passed, and the data would be c. C metadata would be passed for the new metadata. Metadata is been using and like, iterating over the metadata in new metadata. I mean, we'll be using the struct as been defined earlier, of course. Let's see what's where new metadata has been called in the whole file. New metadata is responsible for creating new metadata object to use in info. All right. It will be creating newer metadata object that could be used further in the for the info. Yeah, then later key returns an integer for the metadata keys as well. Over here we'll be using keys. I guess keys will be used at the authenticator as well. Will be used along with an authenticator. Key has been passed. Over here we'll be calling maps.keys m.data and get. Key returns an iterator of the metadata keys, of course. Get will be returning the value of the key from the metadata, returning a copy. It will be returning a copy from metadata that has been called earlier. It will be a case sensitive kind of a value because it is the to lower file was also being passed earlier. Here as well we can see that it's too low. Like the whole language is kind of really case sensitive in that scenario. That's why it's been it will be a lot better. I want to pass the whole thing to traders in a lower format. Like they would be able to standardize the whole thing. That's why. And it would be a lot better as well for the error handling case scenarios as well. The length, if the length of the map has been of the data in it, if it is zero, then it is obviously a nil file. You can also call it as an end of the file, because still it doesn't hold anything, so it would be considered as a nil. Otherwise, if the values in the map of data, if it does hold anything, then it we can consider and return the whole scenario as well. If the length is 0, then also it will return nil. So we are taking care of the error handling over here, I guess. Not the error handling, but we'll take case of the like take we'll be considering about the nil part of these both scenarios. Otherwise, if right, like the variable, I'll be making another string that will be containing the length of the val that has been passed. We'll be copying the ret and the values, and we'll be returning val, like the rel, binding them all together, because rel is yeah, it's a string. It will be like binding it as well for any particular value that you and the whole system will be catching further. All right. I guess we can. I guess it would be a lot better if we hold streams at regular time, because as I can see there isn't as much traffic at the moment, so it is a lot better if we can organize them again at 4 or 5 p.m. Right. I guess we'll break uh, this whole live for now. We'll jump back and we'll get to know a bit more about the OpenTelemetry in the next live stream, I guess. And or either we can get to know about some other components of Kubernetes itself instead of just going over the observability part. Because even in the Kubernetes, we does have a lot of different components of that does help in getting over the concepts of the observability part as well. Like if you can even just kind of hang around along with the open operating systems as well, like the OS commands as well. Like if you want to make or announce any particular node or the pod is like, it won't be a telemetry part. You can use and get a bit glance over the logs and metrics as well. But still, if you just want to be a lot more efficient, then in that case you can just consider any particular pod that is that um, have been, if any particular pod haven't been scheduled to any particular node for a really long time, then you can consider that node as a dead, like dynamically. Because if that node does get any pod schedule on it, then you can consider it as alive in the later time. It's in just general like the OS usage of the different resources within your whole Kubernetes cluster. Right, so let me know if anyone does have any particular doubts, or else we can just call up the stream and we can consider organizing it again, like holding it again, maybe tomorrow or at some other day. Yes, right. I guess it's all done, and we'll say bye, good night, and Radhe Radhe. Yes, yeah.